Let's talk about inverse functions. The first thing I want to talk about is the notation for an inverse function. So the notation for the inverse function of f of x is f inverse of x. And we write that as a -1 in the exponent position. But one thing that's really important is be careful. F inverse of x with that -1 in the exponent position is not -1 as an exponent. It doesn't mean 1 over. That would be 1 over f of x would be written with a bracket f of x and then a -1 on the outside. And generally, we don't combine those two notations in the same introductory section. So the notation that we're going to use is exclusively f inverse f to the -1 in the exponent position of x, or f inverse of x. Okay, so now here's the main idea of what an inverse function is. An inverse function, or f inverse, undoes all of the operations that f of x applies to x. So, for example, if you have f of x equals x cubed plus 7, its inverse function would be, instead of x cubed, it would be a cube root. Instead of adding 7, it would subtract 7, and it would even do it in the opposite order. So where order of operations would say do the exponent first and then add 7, for this inverse function, doing the inside first would subtract the 7 first and then do the cubed root second. Let me show you a more, a broader, I guess, application. Here I have directions traveling from Sierra College in the Rockland campus to American River College. So we're going, and I did this on my iPad, which looks just like it does on my phone. So I'm traveling from Sierra College in Rockland to American River College. And it tells me to leave Sierra College and turn right in 30 feet and then turn left in half a mile and so on and so forth until I arrive at American River College. Now in my phone, when I want to reverse those directions, I travel down to American River College and then I want to go back the other way, this is what I do. I open up my routes and I change my input, which was my starting location, with my output, which was American River College. So I have this little operation in my directions tab that I can change the inputs and the outputs. And what that will do is that will undo input Sierra College, output American River College, and it will go the other direction. Now I've switched the two, and I should be undoing that route. So now my input was my output, and my output was my input, and now my new route, when I click this, should take me the opposite, should undo everything that was done. So let's take a look at that. Now, sure enough, I'm starting at American River College. I'm going to Sierra College. I'm going back. All of my right turns have turned to left turns, and all of my left turns have turned to right turns, and the order has even been reversed. So just by switching my inputs and my outputs, my directions have undone themselves to take me back to the original. So let's try that with algebra. For our first example, let's find the inverse function for f of x equals x cubed plus 7. And as we go along, I'm going to write the steps down that I want you to follow when we find f inverse. So steps to find an inverse function. Okay, The main step is we want to switch our inputs with our outputs. And in algebra, our inputs are usually the x's and our outputs are usually the y's. So we want to switch our x's and our y's. The biggest problem here is we don't have any y's in this function. But we know what y is. Y is f of x. So the very first thing that we want to do is we want to replace f of x with y. So that will be y equals x cubed plus 7. And now we can do that most important step, and that is switch your inputs and your outputs. Or for algebra, switch your x's and your y's. And fortunately, that's as easy as changing y equals x cubed plus 7 to x equals y cubed plus 7. Great. Now, technically, that's a very unsimplified version of what our inverse function is. We want to get it into a much easier to use form, so the third step is really important, and it tends to be where most of the work is. We're going to now isolate our new y. So let's see, isolating that y, we'll subtract 7 from both sides. So I have y cubed equals x minus 7. And then to get rid of the cubed around the y, we'll take the cube root of both sides, giving us y equals the cubed root of x minus 7. Thankfully, it's an odd root, so I don't have to put a plus or minus sign. And that is our inverse function. Inverse function of f inverse, is equal to cubed root of x minus 7. And just like on the previous screen, we know that this is the inverse function for x cubed plus 7. Now, before we go on to the next example, I want to show you something that is really, really neat. So watch this. Let's find for this f of x, let's find f of 2. So that means take f of x and plug in x equals 2. So that would be 2 cubed plus 7, which is 8 plus 7. So f of 2 gives an output of 15. Okay, so when we plug in x equals 2, we get an output of 15 for f of x. Now let's switch gears. Let's take our f of inverse, and I want to plug in x equals 15 into f inverse. So I want to plug x equals 15 in here. So that will give us the cubed root of 15 minus 7, which is the cubed root of 8. Cubed root of 8 is 2. So f inverse of 15 brings us back to 2. So while the ordered pair x is 2, y is 15 is on f of x is 15 and y is 2 is on f inverse. But you know what? That totally makes sense, because the main idea was to find the inverse function, you switch the x's and the y's, the inputs and the outputs. So it makes sense that ordered pairs would be no different. If 2, 15 is on f of x, then switching that x and y pair should be on f inverse. Super cool. Okay, let's do another example. Okay. Let's find, for example 2, the inverse function, or g inverse, for g of x equals the square root of 3x plus 2. Okay, so we're going to follow these 3 steps over here. Just because we name our function g instead of f doesn't change the steps. So instead of replacing f of x with y, we'll simply replace g of x with y. So y equals the square root of 3x plus 2. That most important step of switching the x's and the y's makes this x equals the square root of 3y plus 2. And even though that was the most important step, it wasn't the most difficult. The most difficult is isolating this new y. So let's see, to get the y out of the square root, let's square both sides. And that will give us now x squared equals 3y plus 2. Subtracting 2 from both sides and writing it 3y equals x squared minus 2. And then one last step of dividing by 3, I have y equals x squared minus 2 divided by 3, or I can write g inverse equals x squared minus 2, all divided by 3. Okay, let's do 2 more quick examples. Okay, for this one, let's find the inverse function for h, or h inverse. And just in case you think that we only play with x's and f of x's and y's, let's change the x's to t's. But the important point is that we're switching our inputs and our outputs. So all the other steps stay the same. So our first step, our function, we're going to replace with y. So instead of h of t, we're going to write y. Y equals 5 over t plus 4. Now instead of switching our y's and our x's, we'll switch our y's and our t's. So t equals 5 over y plus 4. Okay, now the hardest part, isolating the new y. So let's multiply both sides by our denominator to clear the fraction. So y plus 4 will cancel with the y plus 4. So I have t times y plus 4 is equal to 5. Now remember our goal. Our goal is to isolate y. Well, instead of distributing the t through, which would be perfectly acceptable, it's a lot quicker to divide both sides by t. So now we have y plus 4 equals 5 divided by t. And that final step, subtract 4 from both sides. So we have y equals 5 over t minus 4. Or in other words, h inverse of t is equal to 5 over t minus 4. Great. Let's do one last example. Let's find the inverse function for f inverse, when f of x is equal to x minus 5 over 2x minus 3. Now, the important step isn't what's hard here. That's the step in red, step 2. It's that last step of isolating y that will be difficult. But the first couple steps won't be so bad. We're going to switch out f of x with y. So y equals x minus 5 over 2x minus 3. And then we're going to switch all of our x's and our y's. X equals y minus 5 over 2y minus 3. Okay, now here comes the tricky part. The tricky part here is isolating the y. Just like in the last example, I definitely want to get y out of the denominator. So multiplying both sides by 2y minus 3 is crucial to get the denominators to cancel. So I have x times 2y minus 3 equals y minus 5. Now here's what's really important about the difference between this example and the last one. In the last one, dividing by the variable in front was fine for isolating that y, but here we have y's on both sides. So our kind of intermediate goal here is going to be to get all of our terms with y's on the same side in the numerator. So the first thing that we're going to do, the only thing that I see to do, is to distribute the x through, giving us 2xy minus 3x equals y minus 5. Now I can more easily do this, get all of the y's on the same side by, let's see, how about adding 3x to both sides and subtracting that y from both sides. Now remember, just because this has a y and this has a y doesn't guarantee they're like terms. This term has an x and a y, so 2xy minus y are not like terms. They're just going to stay 2xy minus y. And on the right-hand side, the y's cancel, and we have 3x minus 5. Okay, so we've achieved our intermediate goal of getting all of the y terms on the same side in a numerator. 2xy minus y are on the same side, and everybody without a y is on the other side. Here's the beautiful thing about having all of the terms with y's on one side. They're a common factor, so we can factor out the y, leaving us with 2x minus 1 in parentheses, and 3x minus 5 on the other side. So since I'm writing a little bit low, let me write that up here. We have y times 2x minus 1 equals 3x minus 5. And the only thing left to do is to divide both sides by 2x minus 1. So we have y equals 3x minus 5 divided by 2x minus 1, and y was f inverse. So f inverse is 3x minus 5 over 2x minus 1.